Good morning, everyone. Last class we have seen few problems on block diagram reduction technique. In today's class, we shall continue the problems on block diagram reduction techniques. So we shall see the problem here. Here in the question, a block diagram of a closed loop system is given and we have to determine the transfer function C of s by R of s here. If you see the block diagram, here we are having the block G1 of s, G2 of s in forward path, and in feedback path we are having H1 of s and H2 of s, and with two summing point is given. So we shall see how we can reduce this block diagram to determine the transfer function. First, if you see in this block diagram whether there is any series block. See here, there is no such series block and also no such parallel blocks and all, no feedback. Then what we can see? Then we can see whether there is possibility of adjusting the summing point. Adjusting the summing point means we can split the summing point or we can combine the summing point as per our need. So see here in this block diagram we are having a combined summing point with three inputs. The polarity plus plus minus. So we can split this summing point. If we split this summing point, we'll be able to obtain a negative feedback loop. Okay. So with the three inputs given to the same summing point, we can't consider it as a negative feedback loop. While splitting the summing point, we can take a negative feedback loop here. So we need to split the summing point. So how we can split? So here we need a negative feedback loop. So the first summing point should have the input from G1 of s and the input from R of s with positive sign. Okay. And then the next summing point can include the input from the first summing point and the feedback path H2 of s. If we split so only, we'll be able to have a negative feedback path like this. Okay. Then we can reduce this negative feedback loop. So here we can reduce this negative feedback loop. So as per the formula from the rule obtained, for negative feedback loop, this is the formula G by 1 plus GH. While obtaining so, here we are having G2 of s instead of G and H2 of s instead of H. So while substituting the values in the formula, we will be obtaining G2 of s divided by 1 plus G2 of s H of s. The rest of the block diagram is same as the previous second step. Okay. Then what we can do? There is no series block, there is no parallel block, but there is a possibility of obtaining a parallel block because here we are having a summing point and here to this an input is given and the input is given from here. So if we do some corrections in this path, we may be able to obtain a parallel block. That is, if this summing point is moved after this summing point. The first summing point is moved after the second summing point. We may be able to get a parallel blocks. But directly we can't move the summing point after this block G1 of s and the summing point. It is not available in the rule for block diagram reduction technique. So we have to move this summing point one by one. That is, first we can move the summing point after this block G1 of s. Okay. So while moving a summing point after a block, what is the rule we have to follow? So the summing point, the input given in upward or downward direction should include that block. Okay, that is the rule for moving the summing point after the block. So here we are going to move the summing point after the block G1 of s. So we have to include this block G1 of s in this downward input given to this summing point, that is G1 of s is included along with H1 of S like this. See here, the step 4, we have moved the summing point after the block G1 of S, and we have included this G1 of S in the downward input given to the summing point. Okay, this is as per the rule. And next, to obtain the here a parallel block, what we can do? We can interchange the summing point. Thus, we may obtain a parallel block in this side. See here, also we are having two blocks in series. This G1 of S and H1 of S is available in series. So, we can combine these series block. How we can combine the series block? By multiplying G1 of S into H1 of S. Okay. See here, the step 5, we obtained G1 of S into H1 of S. And here, the summing point is to be interchanged. So, for interchanging a summing point, if you check the rule means, the corresponding input to the summing point should be same. So, with that in mind, we have moved this summing point, the second summing point with the plus and plus sign to the first position. The same input R of S and G1 of S given to the summing point. And then we are moving the first summing point in step 4 to the second position. The same input given from the forward direction and in the feedback path G1S, H1S. Thus, we have interchanged the two summing point in step number 5. See here, after doing all such corrections, we have obtained a parallel block. See here in this parallel block, one input is G1 of S given to the summing point with positive sign. See here, another input to the summing point is without a block. If here we are having the signal without the block means here we can take it as 1. Okay. Here this parallel path we are having 1 here. So 1 available with positive sign to the summing point and G1 of S available with the positive sign to the summing point. So what is the rule for combining the parallel blocks? This 1 plus G1 of S can be obtained. See here, G1 of S plus 1. That is this parallel path. Here there is no block. So we are taking it as 1. So 1 plus G1 of S will be obtained after solving this parallel block. See here, we have obtained such block. Next, the right side if you see, here we are having a negative feedback loop. So we can solve this negative feedback loop. What is the formula for negative feedback loop? G by 1 plus GH. So instead of G, we are having this term. Instead of H, we are having this term. So here, the substitution is shown. G2 of S by 1 plus G2S H2S divided by 1 plus G2S by 1 plus G2S H2 of S into G1S H1 of S. Okay. Here we can take LCM of the denominator. After taking LCM of the denominator, the C means this 1 plus G2 of S H2 is common to both the numerator and denominator. We can cancel these things and the remaining term will be like this. Okay. So if you see here, from the step 5 to step 6, we have eliminated this parallel block as well as this negative feedback loop. Thus, we have obtained the block diagram shown in the step number 6. Clear? Next, for further simplification, you see here we are having two blocks in cascade. So, if two blocks is available in series or cascade, we can just multiply those two blocks. So, simply multiplying these two blocks, that is G1 of S plus 1 into G2 of S divided by 1 plus G2 of S H2 of S plus G1 of S, G2 of S, H1 of S. We obtain a single mathematical expression. That is none other than our transfer function C of S by R of S is obtained. Okay. So I shall repeat the procedure once again. So in this problem, first we are going to split the summing point. After splitting the summing point, we will be obtaining a negative feedback loop. This negative feedback loop is solved as per the formula given in the rule. That is G by 1 plus GH. By substituting the values given in this block diagram, we obtain the block diagram as this. Then we can move the summing point after the block G1 of S. So while moving the summing point after a block, we need to include that block in the input given in upward or downward direction. Here we are having the input to the summing point in downward direction. So that block G1 of S is included here. Okay. Then we can interchange the summing point. The same step number 4, we can also cascade the two blocks G1 of S and H1 of S, which is available in series. While doing so, we will be obtaining the block diagram as this. Here if you see, we are having a parallel block in left side, and here we are having a negative feedback loop in the right side. So solving those two components, we will be obtaining the block diagram like this. And finally, here we are having two blocks in cascade. So thus we can write the cascaded blocks in series simply by multiplying those two blocks. Thus we obtain the transfer function. Okay. Next we shall see the next sum. The second sum also we need to find the transfer function, and here also a block diagram is given with 3 blocks in forward direction and 2 blocks in feedback path with 3 summing point is given. So first of all, we can check whether there is any series block or whether there is any forward block or whether there is any feedback loop. So no such possibilities is there in the block diagram given. Then we can say check whether there is any possibility of adjusting the summing point. No. Then whether there is any possibility of moving the summing point before or after the block. No. Then we can check whether there is any possibility to reduce the block diagram by moving the branch point. If you see so, here if we move this branch point after the block G3, then we'll be able to obtain a negative feedback loop. So we are going to move this branch point after the block G3. So for moving the branch point after the block, what is the rule to be followed? We need to introduce that block. Here the block is G3 in the branch point, that is 1 by that block should be included in the branch point which is moved after the block. See here, for moving this branch point after the block G3, we can introduce, see here we have moved this branch point after the block G3. For that we have included 1 by G3 in that branch point path. Okay. Thus we have obtained the block diagram as shown here. Next, we can see here we are having the two blocks G1 and G2 are in series. So we can reduce that block G1 and G2 in series as G1 into G3. Okay, this G2 and G3 block in series is cascaded to form G2 into G3 block as shown in the step 3. Next, here we are having one more blocks in series, that is H1 and 1 by G3 is also available in series. So we can simply multiply H1 into 1 by G3 and forming it in a single block like this. So here the step 3 we have reduced two blocks which is in series G2 G3 H1 by G3. Okay. Next you can check whether there is any more simplification, any series combination or parallel combination. No such thing. Then if you see here we are having a negative feedback loop. Why it is a negative feedback loop? The feedback path H2 is fetched to the summing point with a negative sign. So it is a negative feedback loop. So what is the reduction formula for negative feedback loop? This G by 1 plus GH. So here instead of G we are having G2, G3. Instead of H we are having H2. So while substituting the values we will be having the equation like this. Okay. Only this negative feedback loop is solved. The negative feedback loop, the forward path G2, G3 and the feedback path H2 along with the summing point is gone and we got a single block with the reduction formula. Okay. The rest of the block diagram is as per the previous step number 3. See here. If you see here again we got two blocks in cascade. There is a block G1 and the block G2 G3 by 1 plus G2 H2 G3 is in cascade. So if it is in cascade, simply we can multiply the two blocks and we can form a single block. See here we have formed the same thing. The rest of the others same as in the step number 4. So here we are having this block diagram in step number 5. Here if you see we are having a negative feedback loop. So this negative feedback loop can be reduced as per the formula. So what is the formula for reducing the negative feedback loop? G by 1 plus GH. So instead of G here we are having this term. Instead of H we are having H1 by G3. Here the step number 6, simply instead of G this block is substituted and simply instead of H this block is substituted and the block containing the equation is given. See here in the step number 6 we are having a feedback. This is a negative feedback, but see here in the feedback path we doesn't have any block at all. So we may consider here it is as 1. Okay, because the same C of S, that is the output is directly fed to the summing point. So we'll be taking here the feedback path gain as 1. Okay, so it is known as unity feedback. Here in the feedback path we are having only 1. So it is named as unity feedback loop. So we can consider this unity feedback loop also as a negative feedback because this one is fed to the summing point with a negative sign. Okay. So we can take it as a negative feedback loop and we can use the same formula for reduction. What is the formula for reducing the negative feedback loop? G by 1 plus G into H. So here instead of G we are having this term. Instead of H we are having 1. So substituting we'll be having the values after substitution like this. Here if you see you can take the LCM for the denominator. And if you see the numerator and the denominator, we are having 1 plus G2 G3 H2 plus G1 G2 H1 common for both the numerator and denominator. So after taking LCM of the denominator, we can cancel the two terms in the numerator and in the denominator. Thus, we can simplify this equation into a single mathematical expression. This is nothing but a transfer function, that is C of S by R of S. Okay. So I shall repeat the steps what we have done for this problem once again. So here this problem, first of all we have moved this branch point After the block, G3. So for moving the branch point after a block, we have to include that block. That is 1 by that block is included in the branch point path as shown in the step 2. And while doing so, we'll be obtaining two blocks in cascade. See here in step 2, we are having G2, G3 in cascade and H1 and 1 by G3 in cascade. So while combining the cascaded box, we'll be obtaining the block diagram as like this shown in the step number 3. Next, here if you see the step number 3, we are having a negative feedback loop. So this negative feedback loop is reduced as per the rule, and then we can find another one set of blocks in series. So that two blocks are combined as shown in the step number 5, and here in the step number 5 we can see a negative feedback loop that is also reduced as per the formula, and we got this block diagram as shown in the step number 6. Next, if you see in step number 6, here we are having a negative feedback loop, but in the feedback part we doesn't have any block at all. So we can take the feedback path gain as 1. So this is a negative feedback loop with 1 in the feedback path. So using that value, we can simplify the mathematical expression into a single term. Thus, the transfer function is obtained in this problem. Okay. Next, we shall see this problem. So in this problem, also we need to find the transfer function C of S by R of S. See here we are having G1, G2, G3, G4 blocks in forward path and H1 and H2 blocks in feedback path, and 3 summing points are available. Okay. Here we shall search whether there is any series block, no series blocks, whether there is any parallel block, no parallel block, whether there is any feedback, no feedback loop also, whether there is any possibility of adjusting the summing point, is combining or splitting the summing point, no such thing, whether there is any possibility of moving the summing point after a block or before a block, no such thing also. Then if you see whether there is a possibility of moving a branch point, yes, we are having that possibility. See here, if we are moving this branch point before the block G4, we are moving this branch point before the block G4, we will be able to have a negative feedback loop. Okay, so keeping that in mind, we can move this branch point before the block G4. So as per the rule which we have studied in the previous class, moving a branch point before a block, here we are going to move it before the block G4. So for doing so, what we have to do? We have to include that block in the path of the branch point. So for moving the branch point before a block, say G4 here, we have to include that block G4 in the branch point path. So here we'll be including this G4. See here, thus we have obtained this block diagram by moving the branch point before G4. Okay. After that, if you see in the step number 2, here we are having two blocks G1 and G3 in series. So we can combine this series block. That is simply multiplying this H1 into G4. Thus we have obtained in a single block G4 H1 in step number 3. So also for simplification, for easiness, we can split this branch point. See here in this branch point we are having a feedback to H2, also a feedback to G4, also a feedback to G4. All these three branch points are available here. For easiness, we can split into 3 separately. So while splitting, if you see, first what we want, what is the idea? for moving this branch point here? For making a negative feedback loop. So, first we can keep this negative feedback loop branch point. Next we can keep the negative feedback loop of H2 feedback path. And after that we can keep G4. Why I am saying means this G4 is a smallest feedback path compared to this H2. See, this H2 feedback path is a smaller feedback path compared to G4 feedback path. So only after this branch point we have kept this H2 branch point. After that the G4 branch point is kept as shown in the step number 3. Next, here we are having a negative feedback loop. So we can simplify this negative feedback loop. Here, what is the formula for negative feedback loop? G by 1 plus GH. So instead of G, here we are having G3. Instead of H, we are having H. G4, H1. So while substituting the values in the reduction formula, we will be obtaining G3 by 1 plus G4 H1 G3. Thus we converted it into a single block. The rest of the thing same as in the step number 3. Okay. And after converting this negative feedback loop, if you see here we are having G2 and this block G3 by 1 plus G4 H1 G3 in series. So we can combine these two cascaded blocks. How will be combining? Simply multiplying those two blocks and forming a single block. See, this formed in this step number 5. This G2 G3 divided by 1 plus G4 H1 G3. Okay. So after that, if you see here, we are having a negative feedback. The negative feedback path, we are having H2. So while solving this, why we are saying it is a negative feedback loop? This H2 is fed to the summing point with negative sign. So only it is a negative feedback loop. So what is the formula for negative feedback loop? G by 1 plus GH. So instead of G, here we are having G2 G3 by 1 plus G4 H1 G3. Instead of H, we are having H2. See here, we have substituted those values in the negative feedback loop reduction formula. We have obtained this equation. See here, by taking LCM in the denominator, we can cancel this term 1 plus G4 H1 G3 in both numerator and denominator, and the rest of the equation is shown in the step number 6 after simplifying this. Okay. Next, here in the step number 6, you all can see here we are having the two blocks G1 and this block in series. So we can cascade it, can combine it by just multiplying the two blocks and forming a single block. After that, if you see, here we are having a negative feedback loop. This G4 is fed to the summing point with the negative sign. Okay. So we can again simplify this negative feedback loop. So what is the formula? G by 1 plus GH. So instead of G, we are having this value. Instead of H, we are having G4. By substituting the reduction formula, we will be having equation like this. So again, we need to take the LCM of the denominator and then we can cancel 1 plus G3, G4 H1 plus G2, G3 H2. This is in the numerator and denominator, and the rest of the equation after cancelling, the rest of the mathematical term is shown in the step number 8. Okay. See here, the step number 8, we are having two blocks. This block and this block. G4 is available in series. So we can cascade those two blocks. So cascading the two blocks means can simply multiply those two blocks. After multiplying, we obtain the single mathematical expression, which is our transfer function C of S by R of S. Okay. Thus, we have obtained the transfer function in this problem. I shall repeat the steps once again for better understanding this problem. So here in this problem, what we are doing? First of all, we are moving this branch point before this block G4. While doing so, we have to include this block G4 in the path of the branch point which is moved. So here, see, this G4 is included in the branch point path. And next, we can combine these two blocks, H1 and G4, which is in series. And then for easiness, we can split this three branch point combined here. As such, we obtain the block diagram shown in step number 3. Next, here in step number 3, we are having a negative feedback loop. So this negative feedback loop can be simplified as per the rule. After that, in the step number 4, you all can see the two blocks again in series, and these two blocks are cascaded. That is simply multiplied and formed a single block. Then we are able to find another negative feedback loop. So, we can also simplify that negative feedback loop, and it is shown in this step number 6. And in step number 6, you all can see the two blocks G1 and this block is in series. So, we can multiply these two blocks and obtain a single block. And next, if you see here, the step number 7, here we are having a negative feedback loop. By the formula, we are reducing this negative feedback loop. See here, in step number 8, we have a reduced negative feedback loop. And then again in step number 8, you can see these two blocks in series. So if the two blocks are in series, simply we can multiply those two blocks. So thus, we have obtained the transfer function. Okay. So in today's class, we have seen 3 problems on block diagram reduction technique with the 11 rules which we have seen in the previous classes. Okay, thank you.